All right. Welcome, everybody. I think we've gone live. I want to thank everyone for coming this morning. I've only got 20 minutes, so I'm going to go a little bit rapid fire here. We're going to talk about some of the steps that you and your organizations need to be taking to modernize your data science and analytics roles. So the premise behind this is that everything's gotten far, far more complicated in recent years. I don't think this is a surprise to anyone. But whereas even 10 to 15 years ago, there tended to be a few analytical tool sets, a few analytical platforms, some commonly used algorithms. Today, we've got wide variety of tools, vast new platforms, including the cloud. We've got AI. And so all of this necessitates rethinking the roles that you have and how you organize your team. And as well, if you're someone in your career, what type of job do you want to have as we move forward? So there's going to be 5 specific roles that I'm going to cover today: data engineering, analytics or data translators, analytics interface and application developers, operations roles, and then chief data scientists. I'm going to go into each of these, explain a little bit about what they're all about, and then I'll loop back and tie them all together. So first, data engineering, it's become a big thing. This is probably the most adopted of the roles I'll discuss today, and that almost every large organization has data engineers in place. But what suddenly made them become an urgent need? If you go back not that long ago, there were effectively 3 data roles prior to the rise of big data in the cloud. And that was, you'd have people who worked on source systems like a point of sale system, transactional system, et cetera. You had people who worked in what was known as ETL that would get the data from a source system into a repository. And then you had what were largely DBAs or database administrators who oversaw those repositories, which for many years were largely relational databases. And each of those roles is still here today and still serving critical needs. But as the open source movement exploded, as big data exploded, bringing different types of data, and then the cloud added even more complexity on top, suddenly it wasn't as easy as it used to be to simply pull together your data for a project. And that's where data engineering suddenly became a thing. Especially in the early days, data engineers were effectively having to figure out how to string things together to create a data pipeline. Often those tools were very immature, not well documented. The way they were combining the various tools may have never been done before, or certainly wasn't well documented anywhere. And of course, the specific use cases they were trying to support may have never been used in context of that tool set. So it was a very difficult process, and it involved really something similar to Rube Goldberg, stringing things together so that they kind of barely worked well enough. And that's important, right? I'm not belittling that at all, but it was really the immaturity of the space. The big difference as well is that traditional data people were really optimizing within an environment, right? You had ETL people optimizing the transformation and transfer of the data. You had DBAs optimizing queries and the storage of that data. Data engineering is a lot more about holistically managing an entire span of a pipeline across multiple tools and potentially multiple platforms as well. So it's got some additional complexity. Now, the maturity level of a lot of the tools, as well as the discipline as a whole, is rapidly increasing. And there's starting to be a lot more tooling available to automate a lot of what data engineers are doing, or at least make it easier for them to do it, as you'd expect. But this role is not going away anytime soon. Then we get into what's known as translator roles. And most companies and organizations have someone serving this role, whether they think of it or not. Right? There's always that person who's really good at dealing with the business or the client that the analytics and data science organization puts forward. As organizations grow and you start to have more scale, it's really important to formalize this as a role that someone does as part of their job initially, and eventually, if you're a big enough organization, probably have people full-time in this role. And this is not a project management role. This is specifically not a tactical project manager role. That's a big mistake organizations make. They throw in a project manager. It's also not a junior role. This is somebody who has to understand the business well enough to do the translation, understand the analytic data science side well enough to do the translation, and has to have the respect and credibility with both those organizations. This means somebody with a pretty good level of experience, maybe even a high level. I see, in time it being director, VP levels who move into a role like this, specifically not junior folks. But one of the key questions is this a business person who becomes a translator or a data science person? I've seen both work, and I think either can work. It's really about having somebody who's understands both of those worlds well enough to pull it off. So you could look in both the business side and the data science side for these people. Just from critical mass of where do you tend to have the most headcount, over time you may end up with more people coming from business, just because typically the business is going to be a much larger organization than the data science organization would be. Now, another role that really is a translator type in and of itself is interface and application developers focused specifically on analytics and data science. And this is becoming necessitated because now the analytics that we're building are embedded in business processes, as well as both employee and even sometimes end customer facing applications. And this requires displaying to them information that may be analytically derived in a way that they can consume that. And again, this is one of these things where, can data scientists use tools like Shiny and R to put out a pretty basic app pretty easily? Well, yes, but let's face it, the average data science person's not going to be able to put out a really awesome user interface that looks great and that has certain design patterns that are accepted by those who are experts. So just like everything, there's people who develop interfaces, who do design and engineering of this type for a living. It's best to let them handle this. Now, as they start to deal with more and more analytical processes and output, they'll become very well versed at some of the special requirements for how to best surface those analytics to a variety of different types of end users as is needed. So I see this evolving, but this is, again, another type of a hybrid role, as I think all of these are. One of the newer roles that's really exploded in the last 2 years or so is operations roles. And this has many flavors. There's machine learning ops or ML ops. There's AI ops, data ops that kind of started it all. Now, as it relates to analytics and data science, this one's an intriguing one because now we're really getting into some hardcore systems engineering, some hardcore processing optimization. This is in a very technical computer science, knowing how to manage processing space. The average data science resource isn't going to necessarily be good at this. So when you think about it, some of our modern processes might involve graphics processing units as well as CPUs. It might have a variety of cloud resources it has to utilize, and all of those have both costs and have time associated with having them do their part of the execution. And so this role is really important as you talk about scaling. They're both going to make sure that the process is running as it should, but also that it is running with the level of performance and level of cost at an optimal level that's required. So this is one where, again, as someone begins to work more in the realm of data science and algorithms, a really good engineer or ops person is able to understand those processing profiles and needs better, and therefore become better at optimizing them. And so this is kind of the hybrid between, again, a classic systems person and a data science person, but again, becoming more and more important as we attempt to scale. Most organizations have some variation of this in place, whether directly or indirectly, and these still seem to be heavily coming from the IT side of the house, the classic system side, more than the data science side. Although, obviously there's, as always, there's people coming from both directions. One of the really neat things over the last several years to have watched is the rise of analytics, data science, and having it get to the point where we now have chief analytics officers, chief data officers, chief analytics and data officers, et cetera. That's great because it means that we now have executive leadership, and it's recognized that this field is worthy of executive leadership. But here's the catch. As you move up the chain and you become an executive, and I spent a number of years as a chief analytics officer myself, I started spending time on very different things. I had a big organization to manage. I had to deal with the other executives to get buy-in for our initiatives, for our budgets, et cetera. And I was spending less and less time actually defining individual projects in any detail. And so as the chief analytics officer, chief data officer type role gets in place. And as people really get worked into that role, they're by necessity going to be pulled away a little bit from some of the operational things they may have been more involved in when they were at a lower level and or when the organization was smaller. So this idea of a chief data scientist is borrowed from some other technical disciplines. The idea is this is yet another translator between the strategy set by the executive tier and the execution work done by the data scientists on the ground to help make sure that the vision that's set forth is met. And this is very analogous. If you go to research and development organizations or traditional engineering organizations, they often have fellows, as they call them, who are really just very senior technical people who didn't want to go on a management track, but who know how everything works and really help make sure that things are going smoothly. That's what I see this being like. This chief data scientist would be very experienced, maybe one of the most experienced people, may or may not have a team. It certainly might be a smaller team, but they'd have a heavy influence in terms of setting the scoping and the direction of the teams getting the work done. But then again, translate what's working and not back up to the executive level and translate the latest vision from that executive level back down. So it's a little bit of a give and take. And I think the combination of that chief data scientist with the chief analytics officer could be very, very powerful. So how do these all fit together? When you think about it, take any generic analytical process. You start with defining your problem and the approach you're going to take analytically. That's where obviously the translators come in, as well as data science generalists. The folks who have a broad range of ability, who are going to do the triage to say what type of analytics and data science methodologies are going to be required and what specialists do I get involved. We then move into the acquiring and preparing the data. Data engineers come into play. We're already starting to see data engineers become specialized. Some may specialize in streaming, some may specialize in hybrid environments, et cetera, but they'll help to get that data available and ready. We then move into the classic modeling and evaluation phase. This is where data science specialists become critical. You might have someone who specializes in predictive modeling or image recognition or language processing. Then what I call the analysts who are full-time focused on analytics, but aren't necessarily as deeply technical. They may do a lot of reporting, a lot of summary statistics and investigation of anomalies and such. And then even citizen data scientists, which are becoming more of a thing that might be doing some of the analysis as well. Then on the back end, as we go to deploy and maintain the processes, those interface developers that we talked about to help make sure that everything's out there that needs to be out there. The ops teams, making sure that it's up, it's running, it's efficient and cost effective. And then the translators come back in on the back end to help with the delivery and implementation and acceptance amongst the business stakeholder community who initially sponsored the work. And so you really have within and across these phases a variety of specialties. And again, if you go back 20, 30 years, all of this would have been basically done by one person. But the data wasn't as broad as it is today. The platforms weren't as broad and the methodologies weren't. And so, early in my career, when I was doing all of these things, it was in a more concentrated space, and it made it possible. Today, it's just not feasible for most people to even remotely do all of these things. And especially at a large company at an enterprise level, you've got so much complexity and so much scale required. You really need each piece optimized, and you'd rather have a specialist. So, as we look at all these changes, what keeps analytics and data science executives up at night? As I've talked to many over the years and think about my own experience, it really ties to that complexity and the fact that all of these roles now are specializing and getting so deep that as an executive, you can no longer understand what everybody on your team's doing. When I was first running smaller teams 20 years ago, I literally could still go in and look at the code of anyone on my team and debug it. And I knew exactly what they were doing from end to end. As I furthered in my career over the years and all of this started to blow up underneath me, I started to have people on my team. I really didn't know what they were doing very much. They were doing things, let's say natural language processing, which I don't have a background in. They were doing those on behalf of the team out in client organizations. And I wasn't able to debug their code or even necessarily give them a lot of guidance. And that's very disconcerting. But what you have to remember as an executive is that the executive role is to be that leader and to help set that strategy. It's not the right use of your time, even if you could, to be down in the weeds debugging code or setting the really specific day-to-day direction of those teams. That's why you have the large team. You need to trust them. You need to let them do their thing. The same theme is problematic even amongst the team, though. When you think about it, as you go across that whole process, it's entirely possible that what a data engineer is doing, the data scientist who gets the output of from that pipeline won't really understand and wouldn't be able to go do everything that engineer did. Similarly, the engineer won't necessarily understand everything the data scientist is doing. On the back end, the ops teams, they're not going to fully understand how the data scientists build those models, but they're probably going to know how to maximize the execution. And again, the data scientists aren't really going to have much knowledge of how those ops people are making it all work. And so it's not just executives who are now struggling with not knowing what everyone's doing. We actually have teams that are each filling a role that aren't able to step into everyone else's. And it's almost like a relay race. You're handing the baton down as we go through to other specialists who can take care of their part. But unlike a race on a track where everybody knows what everyone's doing and you can watch the person do their 100 meters and hand you the baton, in this case, in some respects, it's almost like there's a fuzzy wall between you and the other person. You can kind of tell they're coming your way, and suddenly the baton gets passed through, through the screen that's up, and you grab it and go. You know what you have to do, but you're not entirely sure how that baton got to you or the specifics of that. And that's okay. You focus on what you're good at, and that's what makes it work. That's how we get through the complexity. So the key takeaways: acknowledge and understand this complexity. It's not only present today, it's going to continue to grow, and you're going to have to learn to deal with it. You're going to have to reconsider your traditional roles if you're at the management level in terms of who you have doing what in your organization. If you're at the individual contributor level, you're going to have to think about where you want to fit into this puzzle. There's lots of awesome spots to land, but they're very different. You're just going to want to, find the one that's best for you, and understand there's no dead ends. You could always switch to a different type of role, although it would take some additional training and upskilling to get up to speed, but you're not making a once a career decision here. Start now changing the skills mix and the roles within your organization, roles both in terms of the percentage of time employees are spending on certain things and roles in terms of who you're hiring as a full-on FTE. Enable those outside the organization. As you need this extra scale, this is where things like citizen data scientists and soon citizen data engineers and so forth come into play. Enable the business community to the extent that's possible and the extent you can do it safely to do a lot of things on their own so that they don't need to come to you for everything, and especially not all that basic stuff that's that they can handle and that you'd rather not deal with because you want to get to the fancier stuff. But focus on enabling the entire organization, not just yours. And then as an executive, embrace the idea. You're going to have to trust your people, hire the right team and let them do their thing, and make sure that, the translation is happening between you and the people on the ground through someone like a chief data scientist. But through all this, you can easily succeed. And with that, in case anyone has questions, we're pretty much just about to run out of time. I'll thank everybody and hope this was useful. That's my contact information. And I will say thank you for joining.